Hello, I'm Who Are We, and this is another episode of The Cutting Edge. Today we're going to be talking about the Pre-Motor Cortex, or the PMC. It's a critical region of the brain involved in motor planning, coordination, action selection, and sensory motor integration. While historically overshadowed by the primary motor cortex, or the M1, the premotor cortex plays a pivotal role in complex motor behaviors, including those requiring cognitive control and external sensory input. This lecture will explore anatomy, function, neural circuitry, disorders, and contemporary research on the premotor cortex, with a focus on the controversial topics such as mirror neuron theory, motor cognition, and neuromodulation. The anatomy of the premotor cortex. The PMC is located in the frontal lobe, anterior to the primary motor cortex, M1, and is divided onto two major subdivisions, the dorsal premotor cortex, or PMD, situated in the superior frontal gyrus. It's involved in movement selection and motor preparation, and it receives input from the parietal cortex, particularly from areas involved in visuospatial processing. And then B, we have the ventral premotor cortex, or the PMV. It's located in the inferior frontal gyrus. It integrates sensory and motor information to guide goal-directed actions. It's strongly associated with mirror neuron activity, which has implications for action understanding and imitation. Additionally, the supplementary motor area, or SMA, though distinct, is closely associated with the premotor cortex in motor sequencing. The functional roles of the premotor cortex: motor planning and execution. The PMC translates sensory information into motor commands. It involves the preparation and organization of complex movements, especially those requiring external clues. Sensory motor integration. The PMC receives multimodal sensory input to refine motor output. It helps adjust movement based on visual, auditory, and tactile feedback. Learning and adaptation. Essential for motor learning, especially in skill acquisition and adapting to novel tasks. It's involved in error correction and movement refinement. Mirror neuron system, and this is highly controversial, but it is worth including. Some neurons in the ventral premotor cortex fire both when performing an action and when observing others perform the same action. The system has been linked to empathy, social cognition, and language evolution, though some researchers dispute its significance in human cognition. Neural circuits of the premotor cortex. The PMC, the primary motor cortex, M1, it executes motor commands. The PMC, the parietal cortex, it integrates spatial and sensory information for action planning. The PMC to the basal ganglia and cerebellum. It works for refinement and coordination of voluntary movement. Then we have the PMC to the prefrontal cortex, which is cognitive control over motor planning and decision making. Disorders associated with PMC dysfunction. Apraxia. Damage to the PMC can lead to inability to plan or perform learned motor tasks despite intact muscle function. It's common in stroke and neurodegenerative conditions. We also have Parkinson's disease. Premotor dysfunction contributes to bradykinesia, slowness of movement, and motor rigidity. We also have autism spectrum disorder, ASD, and mirror neurons. Some studies suggest deficits in mirror neuron activity in the PMC may be linked to social and communicative difficulties in ASD, though this topic remains heavily debated. Stroke and motor recovery. PMC lesions can impair motor recovery, making rehabilitation crucial. Contemporary and controversial research. Mirror neurons and cognitive function. Some researchers argue that mirror neurons in the PMC are crucial for understanding others' actions and intentions, possibly underpinning empathy and language evolution. Critics claim mirror neuron activity may simply reflect associative learning, not an innate mechanisms for action understanding. Neuromodulation and PMC plasticity. Transcranial magnetic stimulation, or TMS, has been used to enhance motor learning and recovery in stroke patients. Some studies suggest direct electrical stimulation of the PMC can improve motor function, though ethical concerns remain regarding neural augmentation. Premotor cortex and conscious movement intentions. Recent findings challenge a classical libet experiment, suggesting that PMC may play a larger role in initiating voluntary movement than previously thought. This raises questions about free will and the neural basis of conscious decision-making. Artificial intelligence and brain-machine interfaces, BMI. Studies have shown that PMC activity can be decoded to control robotic limbs in paralyzed patients. The ethical debate revolves around enhancing human movement via artificial augmentation. To conclude and summarize, the pre-motor cortex is a fundamental region involved in motor planning, learning, and sensory motor integration. While research has made significant progress in understanding its role, controversies remain regarding mirror neurons, voluntary movement initiation, and its potential for enhancement through neuromodulation and AI integration. Key takeaways. The PMC plays a critical role in movement planning and sensory motor integration. Mirror neurons research remains a contentious topic, with debates over its role in social cognition. Neuromodulation and AI-driven interventions raise ethical questions about motor augmentation and free will. The PMC is involved in conscious motor intentions, challenging classical views on movement initiation. So, again, thank you for listening. This concludes our lecture on the premotor cortex. Thank you.